Hello and welcome to another video in the How Do I Do Something in CloudBolt video series. My name is Mike Bombard and I'm a principal cloud architect here at CloudBolt. And in this video, we're going to be talking about how do I deploy highly available CloudBolt in Azure. So we'll take a quick look at a reference architecture diagram for what we're going to be deploying. Then we'll look at an agenda, then we'll dive right in. So first, in CloudBolt, when deploying in Azure, CloudBolt's HA mode can support customers' many requirements. So one of the common things I've seen across our customer base in the past couple of years since I've been here is every customer wants to approach this differently. There are different requirements and use cases that every customer needs to take into consideration when they're looking at deploying a highly available application. CloudBolt's operation suits multiple different modes. This is kind of our base model for high availability in Azure, where we would start with 2 nodes. CloudBolt is available to scale out. You can always add more nodes to a CMP pool in the load balancer, or you could always increase the size of the CloudBolt nodes to process additional compute cycles and give more compute power to each of the nodes themselves. Standard HA config, though, we do like to start small and keep things simple when possible. It's very easy to add another node to CloudBolt down the road. So if you find that performance is an issue, you can always add an additional node to the pool. So we will be setting up 2 virtual machines, 2 Azure virtual machines. They will sit behind an Azure load balancer. And then each of these virtual machines will target an Azure Postgres service, as well as an Azure Files NFS share that hosts the shared files that are required for communication between the 2 CloudBolt appliances. So just at a high level, our agenda for this looks like we're going to create the virtual machines. We're going to configure the CloudBolt CMP. We will then go and create and configure the Postgres database. Then we'll create and configure an Azure Files NFS file share. Then we're going to go through the process to actually make sure that everything functions, where we reboot the instances and troubleshoot and make sure that everything is functioning in CloudBolt as expected on each individual node. And then finally, we'll tie everything together with an Azure load balancer at the very end. We'll go through and just show some taking a node offline, how things function. But this should be a very complete walkthrough. It is a little lengthier than some of the other videos, probably coming in around an hour and 20 minutes. But this is a fairly big task, and we wanted to ensure that we were covering things thoroughly. So hopefully this helps out. If there's anything we can do to help, please reach out to your account executive or your customer success manager, and they can help further down the road. Let's get started setting up high availability in Azure. So one of the things I'll point out here, I am making some edits to the actual document. So we're going to be following my markdown as we go through this tutorial. Here within the next couple of days after this video is published, it should be updated in the official document set. So you should be able to go to the setup high availability in Azure document in the CloudBolt portal, moving forward to get updated instruction sets on deploying HA in Azure. Okay, so let's go ahead and get started in Azure. I haven't even created a resource group yet, so I'm going to create just a very basic resource group that we're going to use for all of my resources here. Just call it HA demo, review and create. This way I can tear everything down that I'm creating here with one fell swoop. Okay, so my resource group is created. Now we're going to start to dig into the documentation. So first thing we need to do is to create the virtual machines for housing CloudBolt. They'll need to be deployed on either Oracle Enterprise Linux 8 or RHEL 8 image. I'm actually going to go, you can deploy the virtual machines first or Postgres first or deploy them in tandem. I'm going to start with Postgres. It takes a little bit longer to deploy, so it lets me do things a little bit more in parallel. But also, I'll point out just one thing. It does call attention to it here. Ensure that Azure Database for PostgreSQL Flexible Server is available in your desired region. So I ran into some issues because I'm using a dev or test account in Azure. It wouldn't allow me to create a PostgreSQL database in the East US region, which is where I usually put everything. So I'm just going to start here because if your Azure subscriptions aren't set up appropriately, you may not be able to deploy in the regions you want. And you should have your CloudBolt instances co-located in the same region as your database service. So I'll just show you what that looks like as we're deploying this. So I'm going to scroll down to the Postgres section. So Postgres database server for flexible servers. We've already done that. Subscription and resource group. We just created my HA demo resource group. That's what we're going to use. Server name, I am going to call this CMP HADB. Now, region is where this gets important. So if you notice when I select East US, it should give me an error here. So it's saying that the subscription is not allowed, but this is actually an Azure restriction. I think you can email Azure and get that resolved. In my case, it doesn't really matter that much. So I'm just going to switch regions. And I want to be sure that when I deploy my virtual machines, they go into the same region as notated here. Next thing that's important is Postgres version 14. So make sure that you're selecting Postgres 14. Workload type production is what you will need to be able to select there it is, zone resiliency. Without production, this is not available. So would select production, availability zone. I don't really have a preference. You can put it wherever they want. And then we do want zonal resiliency enabled. This is what enables HA at the database layer. So the reason we recommend the Azure database for PostgreSQL flexible server is because it offloads all of the complexities that have to do with standing up DNS records that move when failovers happen at the database layer, all of those things that would fall to your team to manage if you're not leveraging this service. Next thing I'm going to do is set up an admin. So just look for myself. Okay, I am the admin, and then we're going to give this an administrator login. CB_DBA is what's recommended in the doc. If you use something different, just capture what that different admin login is, and then you'll need to update commands as you go through. Try this one more time. Okay, so passwords are now good. I didn't change the default setting of the size. This really depends on how much you're hitting the database. So I'm going with the default size. I would expect that you could probably leverage a smaller size or a different size, but I think the default size is a good start. Next, we're going to go to the networking tab. So we're over to here. The document actually recommends public access. I am going to update this. I don't like public access. I'm going to go with private access. And I'll put this nuance into the doc here in just a minute, but I'm going to go with private access. I have my subscription, my virtual network. I'm going to create a new VNet. If you have an existing VNet, you'll also need a subnet in that VNet to support the Postgres flexible server. If the subnet isn't tagged for that, it won't be eligible. So you may need to just create a new subnet here. I'm going to let it create all of those for me. And then my subscription is fine. I'll take the default private DNS zone. If you have an existing private DNS zone, you can select that. You'll just need to be sure to capture what that private DNS zone is. Okay, I stepped away for a second, just updated those two instruction sets. So we are going to select private access under connectivity method, and then select a subnet or a virtual network that includes a subnet that's already set aside, or create a new one. Private DNS integration, we're good with all of those things. We should be good to go ahead and create the instance now. Let's just make sure it validates. It is now deploying my Postgres instance. So while that's running, we're going to go back over and I'm going to create some new virtual machines. So if I go to I'm gonna take an intermediary step. Depending on how your environment is set up, you may or may not need to do this. I'm not going to include it in the instructions, but my virtual machines are going to need let's refresh this. They're going to need a subnet to land on. So right now I have my HA demo VNet that has a single subnet in it because we just created it in this resource group. That subnet is only pertaining to the specific IP space for Postgres SQL service. So very likely you already have these existing in your environment today. So you can skip to the next session if that's the case. First thing I need to do is expand my address space. So I'm going to give this a couple more IP addresses for my new subnet that I'm going to create. And then I can go over to subnets. I'm going to create a new subnet. We're going to call this, it's going to be default purpose, but this is going to be VM_net. And address range 10.0.1.0, and I don't need it /24. I can do even just a /26 would be more than enough for my IPv4 space. Enable private subnet, no default outbound access. That'll be all right because it should be able to communicate to the VNet still. Security, I don't need any of these. Network security group, I'll add those on the virtual machines. Again, these are all up for your configuration. I just need to create a VNet for my machines to live on. Again, you probably already have that available. So next thing I'm going to do, I need to go to virtual machines. We're going to create our 2 CloudBolt instances. And there's a couple of ways to do this. Let's go back up to the top. Create virtual machines. We give some very broad strokes. We just need the virtual machines to exist. I'm going to show you one method to do that. You could also create them independently. But I'm going to use Azure's UI to basically, don't need that right now. It takes up too much real estate. Anyway, resource group, we're going to go to my HA demo resource group, virtual machine names. I'm going to call this CMP-0, and we'll change this in just a second. Remember, zone needs to go in the same zone as my database, so I need to find US East 2. And then availability zone, I'm going to select 2 availability zones from here. So from the selection here, I'll select zone 1 and zone 2. And what that will do is it'll spin up 2 virtual machines. I don't like the extra hyphen that they put in here. So I'm going to delete that and edit my names. So CMP01, CMP02 will be the VM names that are getting created. Images, again, Oracle Linux 8 or Red Hat Enterprise Linux 8 would be viable selections as of when this video is being made. So select an image that complies with that. Size recommended for a medium CloudBolt deployment, which serves probably a majority of our customers. I think we support up to 40,000 virtual machines in this configuration. But standard D4 AS v4, check the hardware guide before selecting, but this is, for 90% of what we're going to see is what we would recommend. For the SSH public key, I don't have this stored in Azure yet, so I'm going to use existing public key. Go ahead and paste my key in here. That way Azure has the key. There's extra white space. There we go. So the SSH public key is recognized. Public inbound ports, I'm going to do SSH and 443 at a minimum. I usually do 80 just because, but we redirect to 443 anyway. So this would allow you to have that redirect capability if desired. The other thing that I'm going to look at here. So we have the basic instance details. Disks, you could stick with the default. You could make it a little larger, totally up to you. We are going to create an Azure storage account with the actual shared directory where a lot of the files that CloudBolt creates and write are going to go. So a lot of the disk space requirement will be offloaded to the Azure storage account and the Azure file share. Networking, I am going to look at this. So notice my VMnet is the only one available. It wouldn't let me select default. That's why I had to pre-create that. We are going in the same virtual network, which while we would support across different virtual networks, you may need to put different different networking components in place to make sure that you can communicate. So it's outside of the scope of this specific deployment. We should be ready to go at this point. So I'm going to go ahead, review and create. Again, remember it's going to create my two. Didn't like my networking tab. Required information is missing or invalid. Let's go back to networking, see what. Oh, load balancer. So because I have two instances, one of the things that I can do here, so we're going to take care of the load balancer step. I'm going to do the initial configuration now. We're going to get both of these appliances up and running, make sure that they're both functioning independently. And then as a last step, we'll actually come back and work through the load balancer steps to finalize. There are two options here. CloudBolt would support configurations either using an Azure load balancer or an application gateway. The big difference between the two is that the load balancer, the certificates terminate on each node of CloudBolt. So the load balancer is really just passing traffic through to the appropriate node. In the event of a failure, it then retargets traffic to the other node. As long as the certificate exists on both CloudBolt instances, it should behave as needed. This is the simpler setup. You could also leverage the application gateway as an alternative. This isn't a requirement, so that was in some of our older documentation. We said if you're using SSL, we would recommend this. For application gateway, that's up to our customers. You have some flexibility in the way that we're deploying this. I like the Azure load balancer approach because I like to engineer for the simplest solution that meets my requirements. If you do have a requirement where you need your certificate terminated on the application gateway, that could be a viable option. But we're going to configure everything with the Azure load balancer. And when we get there, maybe we can also look at the application gateway as well, depending on how long this video gets to be. But we're going to start with the ALB, and we can see how this goes. So load balancer name, I'm going to call this CMP LB. Let's go back to my documentation to be sure that I am following along with it. This is going to be all the way at the bottom of the instruction set. So standard load balancer, select a subscription and resource group, which it's already done because it knows where my VMs are getting created. Rules, I'm going to leave these rules here. Load balancer rule, I'm going to start with, you know what? I think for my load balancer, in the documentation, we currently recommend both 80 and 443 rules. For now, though, I'm going to try this with just 443. We'll see how this turns out. And if this goes well, we'll set this up to have the doc update to reflect it. The rest of this should be fine. Back import inbound NAT rule. I don't know that we need forwarding incoming traffic sent to a selected IP address and port combination to a specific virtual machine. Oh, it looks like this would be. Yeah, I left this default before, so we're going to leave that default for now. I don't think we need to change that. So let's go ahead and create. So now we have a load balancer added, so networking should be good to go. Okay, my validation's passed now, so I can go ahead and create. And while this is deploying, let's just look at our Postgres server. So this is still running. This usually takes 10 to 15 minutes. So that should be done here right around the time my virtual machines are complete. All right, looks like my virtual machines are deployed and all of the components that are coupled with them. It looks like the database is still running, which is okay. It's going to be a little bit till we're able to come back to the database portion, but my virtual machines are ready. So the next step would be connecting to my CloudBolt instances to license them. So again, follow along with the documentation. So now we've moved past create virtual machines. Actually, I lied. We haven't deployed CloudBolt yet. So we need to install CloudBolt would be the next important thing to do. So I have my two IP addresses here. I'm going to start to work with those and SSH into each of my appliances. And I don't know if that's going to work for the deployment process. Okay, so this link goes to this document, which is deploy using the CloudBolt installer. We're going to first access CloudBolt's download article for CMP. This will take us to the downloads page where we capture the download URL. So this will always give you the latest release. I would recommend always starting with the latest release. And the installer is the file that we're going to want. So I'm going to right-click this. I'm going to copy link address and just get that into my clipboard so that when I SSH into my instances, I can just pull that file directly down to each of them. Okay, I'm SSH'd into my first appliance. First thing you'll need to do is actually switch user to the root user. This hyphen in the command is imperative, so make sure you don't strip that out. We do need to pull in the root user's environment variables for the install to be successful. We do also recommend stopping Firewall D, as well as temporarily setting SE Linux to disabled during the install. Just there are a couple of things that both of these services can cause some issues. So we're going to go ahead and stop those. Then the next thing we need to do is actually download CloudBolt. So I need to go back and get my window or my link because I already copied something else. I'm going to change over to var TMP and just download here. So I'm going to do a wget and then the URL that we had specified. Once the download completes, I'm going to do a tar-xzf on the CloudBolt installer file so that extracts. And then I'm going to change into the CloudBolt directory. And apologies, these are all in here. So download the CloudBolt installer. It doesn't have the extract command in here, but we have it here. And then once it's there, we're going to run that install cloudbolt.shell. So I'm now moving into my CloudBolt installer directory. One thing I will call out, do not run the install CloudBolt for Red Hat, even if you're installing on Red Hat. That is an older script. You just want the normal script. This will prompt you, just give you a warning like you're running the installer. This will wipe the database. Since this is a fresh instance, we're good with that. It's going to go out and install the CloudBolt application. This will take about 10 minutes and we'll check back in when complete. Okay, so CloudBolt is successfully installed now. What you're looking for is CloudBolt installer successfully finished. Make sure that you see this on both nodes. As long as that comes back successful, you should be good to now go over to each node. And if we find, there we go. So back over to my markdown. Now that we're done, we're completed the deploy cloud management platform step. Now we're going to go over to the initial platform setup. So we have to launch the cloud management platform web interface. You can go to the URL or the DNS name of the server. You will get a certificate error. We'll resolve those here as we go through. You should have a license file sent from either CloudBolt SE or account manager. Most of the time these are pasteable, but I have a file stored on my computer. So we're going to go to my computer to pull that in. And select the license. We're going to apply the license. Make sure you click apply license on the second step. And then it usually takes about a minute and a half to go through and finalize configuration. I'm going to do all of these, the next couple of steps on all of the CloudBolt instances. So you got to go through and configure this on both of the instances. There are some components that the application server relies on being installed with the first instance of licensing. So you can use the same license on both nodes of CloudBolt. Okay, the configuration is done. Now we're going to log in as admin with the password admin for a first login. Accept the terms of the license. We do need to, if you have a proxy, you can set it up now. I don't have a proxy, so I'm going to skip proxy setup. And then the last step we'll do before moving on to setting up HA is we need to put in an admin user name. So it could be yourself with your own email address. It could be a break glass account where you have like a distro for your team. But I'm going to do this cd admin. I I am going to do the plus CB admin here because that will allow me to use my actual email address for my real account. That'll be linked through SSO or Active Directory. Doesn't matter. And then group name for users. You can call this whatever you want. Usually the first group I create, I just call it admins. There we go. Create account. And start using CloudBolt. So I'm going to actually go ahead and exit Wizard here. It should take me back to the main login page, and it should be good to go. I'm going to go run through the same exact steps on the other appliance. The difference being, actually, there is no difference. The account, though, what we're going to do is only use the account created on the first appliance. The second one's going to be thrown away because that database and everything else is going to get blown away. But there are some components that we rely on with this setup step. So make sure you go through setting up the initial user on both appliances, just that way to be sure that everything is set up as needed. So I'm going to pause. You don't need to watch me do this. Okay, moving on. Configure node connectivity. I'm going to leave my public IPs. If you have routing to your private subnets, you can remove the public IPs if you'd like. That's up to you, depending on your specific practices. Upgrade the platform. I don't have to do that because I installed from the latest release. If you did the same thing, I wouldn't worry about upgrading to latest. So prepare for database configuration. So the next piece that we're going to do is to work through setting up our database. So we have, here we go. Okay, so we have our, we're signed into our CloudBolt instance, and we're going to work through this. So there is a file here that if I just cat this file, it's going to show me what the settings are for the existing Postgres password. This is unique per instance of CloudBolt, so I'm going to tear this down pretty quickly after doing this video, so I'm not worried about that leaking out. Plus, once I change the database to be in Azure, it's not going to matter either. So I'm going to go through, we first need to store the password. And let's just go. Okay, so the password is stored, and then I'm going to do a quick dump of the database. cbdba. And we can change over to the temp directory or just list it. Here we go. Our CloudBolt.tar exists. If we wanted to see, just make sure it has something in it. Yep. About 6 megs, if I'm reading that correctly. And run the following command to update permissions on the secret key for CloudBolt. So there is a file that, once this is on the shared file, we'll be referencing this file. So I'm going to update permissions there. Okay. Now we have some of the instructions we've already gone through, the Azure Postgres database. I didn't even check to see if the database is complete at this point, but it should be. Okay, the deployment is complete, so I can go over to my Azure Postgres database instance. Now I'm going to scroll down to configuring the instances to use the database. I've already stored my remote database password, so this would be the password that we used when setting up our Postgres instance. So I already have that stored in my environment variable, but you would need to run this in your environment and replace the curly anything from the angle bracket to the other angle bracket with your specific password. I'm going to go ahead and for this portion, I like to do all of this in Notepad because there's a couple of things that need to be replaced. So I'm going to pull up my Notepad document here. So I do need my username, which we know is CB_DBA. DB name is going to be Postgres is correct. Port should be accurate unless you have a custom port here. And then you need the host name for your CloudBolt database or the database instance here. So if I go over to high availability, you're looking for the primary server name. So this is the name that will go with whatever server is deemed the primary at any point in time. So I'm going to copy that. I'm going to replace my remote DB DNS name here and get rid of the new line. You want that to be on the same line. I'm going to copy my command here and then back over to my CloudBolt instance. There we go. So notice that database CloudBolt doesn't exist. So it's going to drop it. It's going to create it, and it's going to grant permissions to my CB_DBA account. So we've created the CloudBolt database. We're going to keep moving down the line. Each of these commands I'm going to remove. I'm not going to use the export command because I already have it stored for the password, but I am going to have to update each of these commands with my specific information for my environment. PG restore remote DB DNS name we already have. Username would be remote DB user. DB_DBA. And role. Role is also going to be CB_DBA. That should do the trick. The only other thing, I thought I'd fix this, but make sure that there's a space between CloudBolt and /temp CloudBolt tar. Just fix the space in the doc. So that should make it into the doc updates as well. So let's go ahead and, remote DB port. I got to get that one too. It's 5432. And it should be doing the restore now. Now that my database restore is complete, we're going to move on to the next command, which is setting permissions for CBDBA. So again, a couple of things we'll need to replace. Replace the DNS name. Username is CB_DBA. DB name is Postgres. And that should do the rest of it. Okay, it looks like the roles and the grants worked as expected. Back to our doc. Last step is to test the entire thing just to be sure that it works. So build out this URL to match. RootDB port 5432. And the last part that I won't show you because it's my password, but the password, I'll replace this password here in a second. The other thing that I found I had to do last time because of, again, the exclamation point in my password is put single ticks around this entire command just so that it renders as a string. So as long as you do that, put your password in, this should function. So I'm going to go ahead and test it, and I'll show you the output here in a second. All right, so here is actually some output you can see, but what you'll notice, the original command has this Q in the grep, which means that it returns silent. Silent's actually what we're looking for. That means that we found CloudBolt. But if you want to see it print something, if you get rid of the Q, like you can see I did in my command here, where it's just a grep-w, it should show the query responding. So we see that we're connected to Postgres now. I'm just going to clear this real quick to get my password out of the history. And there we go. So we know that we're connected to our Postgres instance from CloudBolt. These steps could be applied whether you're deploying your own Postgres instance or connecting to an existing Postgres cluster of servers that you have set up inside of your environment. Finally, the last and probably the most important step, because we haven't done anything in CloudBolt to tell it that you need to update where the database is stored. So I'm gonna cat this file, my settings local file, and I'm just gonna copy the databases section from here. Don't copy the whole thing. This root directory, if you put it into your customer settings file, will cause all sorts of headache. And then I'm gonna go through and I'm gonna update my var out CloudBolt ProServe customer settings .py file. Just put it anywhere in here. I'm going to put it down at the end. But what we're going to do is we're going to take our databases set here. We're going to need, the big thing you're going to have to replace is the password to match the password for the Azure database, as well as the host that we're going to now be targeting. So if we go back over to my Notepad document, we can grab host name. And then I'm going to update this password and save the file. And then we'll take a look and be sure that, actually, we're not going to do anything yet because we still have to update the files before we go ahead with this. But I'll update the password here, save my file, and then we'll move forward with the next step. Okay, password is updated, file is saved. Now we're moving on. So Postgres, we have our settings updated. We don't, let's do this now. The Postgres service, there's a couple of ways to do it, but here, sorry, let me put this in the user-friendly format. Yeah, so we do want to stop Postgres on the CloudBolt appliances because they're not going to be needed there anymore. So and what I'm going to do is actually change the docs. This databases section needs to be on both of your servers, both the primary and the secondary instance of CloudBolt. So I'm going to shift that here in just a second. But since I'm on my primary node now, I do need to stop Postgres. Okay, so my Postgres service was removed and disabled, or stopped and disabled at this point in my primary instance. Okay, so you see the guidance has been moved into the all instances section. So we're going to, actually, I lied. That doesn't need to be there because we're going to copy this file over to the actual file share. So I'll revert that. The only place that needs to be performed is on the primary node. This file will get copied over here in just a second as we work through the NFS file share. But on the secondary instance, we do want to be sure to stop and disable the Postgres service on the secondary node. So I'm just going to do that real quick while we're here. Okay, Postgres is now stopped on my secondary node. So everything we've performed so far has been primary node, with the exception of stopping and disabling the service on the secondary node. Next step, we're going to configure an Azure Files NFS share. So a couple of commands that we're going to run with the Azure CLI. So I'm going to go ahead and log into the Azure CLI and authenticate real quick, and I'll be back. All right, I'm logged into Azure now, so I can go ahead and move forward with these two commands. So we're going to do, I don't need to do the Azure feature register. I know that it's already done on my account. You can run that if you don't think it's done. I think it's idempotent, so I can run it multiple times, or maybe it'll complain. So this message does say you may have to run a provider register to get the change propagated if for some reason it wasn't already enabled. Next piece is verify feature registration. Probably could have run this first just to verify before running the first command, but it is registered, so we are good to go. Now that that is done, I'm going to do these one at a time. Demo is my resource group. And because I am in PowerShell, I'm going to need curly brackets around it. fix this real. There we go, the $sign. And it was something along those lines. So for Linux, could be slightly different if you're using a Linux command line, but for PowerShell, you're going to want to use the $sign to store your variables. $sign storage account name. Instead of CMP files, I'm going to call this CloudBolt dash. Actually, you can't have a hyphen in a storage account name, so it would complain about that. This may even be too long of a name, but we'll find out. It'll complain pretty quickly here. And then $location equals East US 2. And that needs to be a string. Okay, let's see if we can create the storage account. Recognize the new lines. So let me fix that in the docs. All right, document's been updated. There's no more new line characters in either of these two commands. So we're going to create our storage account, make sure it doesn't complain. Storage account creation is successful, and then we are going to create the file share, the NFS share in that storage account. And that was successful as well. Now we need to go in to configure the storage account. So we're going to jump over to the portal for these pieces. If we go to home and then resource groups, it's all going to be in my resource group. So if I get to my storage account, here it is, CloudBolt CMP files, right at the beginning, of course. Properties and networking. So networking over here. We're looking for public network access. Let's go ahead and manage. From here, it is already enabled. We are going to, instead of enable from all networks, we're going to do enable from selected networks. And then we're going to select our existing virtual network that we set up in the last step. So that HA demo VNet that we've been using for this entire deployment, and then subnets that are able to access this storage account. Let's go ahead and enable. This is now set up, it's enabled. So let's go ahead and add. So now we can see the virtual network is enabled. Resource types, I don't think. We need to select anything here. Right now it's open to just anything. And that appears to be for other types of resources. It can't be isolated from a network. We could also further isolate it just to the IP addresses that we know the instances are coming from. For my specific setup, I'm not concerned about that. You can take that as needed for your specific requirements. So let's go ahead and save our network access. And we now have an access rule with a virtual network that's set up. And let's go to data storage and find file shares. We're going to select our file share. We're going to select connect and Linux. Actually, just connect from Linux. Select your Linux distribution, not RHEL or CentOS. If you're using RHEL, you would use RHEL. I'm going to use Oracle Linux command. I'm not going to use this entire thing, but really what I'm looking for here is this, I can't even copy it. The name of the share here. So that's my actual name. We'll use that here in just a second with our CloudBolt instance. But that's the mount point that we're going to need. So I'm going to put that into my Notepad++ because we'll need it here in a minute. And then I'm going to SSH in my first instance of CloudBolt. I can select the right window. And we're going to do the first command, the first set of commands. You can run these one at a time if you'd like. Okay, so you'll notice that the entire, the mount point that we set up here, we fill most of it in with the exception of we leave filler for the storage account name and its link. So we're going to go ahead and run this command, or these three commands. Make sure that NFS utils are installed. The mount directory was created, and then we're going to go ahead and mount. Access denied by server while mounting. Let me troubleshoot that. I think I missed one critical piece here is why we're failing. It looks like I missed this set secured transfer required to disabled. So we need to update the overview, I believe. Or settings, configuration, secure transfer required. Let's disable that. Let's save it, and then we're going to give this another shot, and it should work this time. There we go. Now we're not complaining. So don't skip over commands like I did. Pay attention to everything there. Okay. So I have the mount up and running. Now I need to move the CloudBolt files over. So these should be fine just the way they are. So I'm going to go ahead and move. And this can take a minute. There are quite a few files out there, even just on a fresh install. So we'll pause and let this run through the copy process, or the move process. Okay, I'm actually going to show the commands on the second node here because we're going to be bouncing back and forth. So I've run step 2 and step 3 on the primary instance already. So I'm going to pull my secondary instance over here. So on the secondary instance, we're going to run those same commands. I still have my NFS command here. Just going to install NFS utils. Okay, we got our mount successfully without any complaints. Now we're going to skip step 3 for the second instance because it's already been moved. So now on the secondary instance only, we need to remove these directories. On the primary instance, those directories have already been moved, so there's no need to remove them because they already exist on the mount. Now on both instances, I'm going to run these commands. We can start with secondary. Storage count, no such file or directory. Oh, because I'd need to update the path again. Okay, so if I grab my storage account name, I can replace all of these. Copy. Try that again. Okay, no complaints from node 2. Wait, cannot create. Oh, my directory is created the first time I ran the command, so that's fine. And then if we go over to node 1, let me just double check. This is node 1. Okay, my make directory and my mounts all succeeded without any issues. Now the last thing we need to do is these fstab commands. We'll go on over to Notepad again and grab probably would have been a lot quicker to just grab the whole name and copy and replace real quick, but already too far in. Okay, so fstab. This is my primary node. No such file or directory, so it doesn't like those. Oh, you know why. It's because I need to edit fstab. So vi etc fstab. And then in here, I'm going to make some changes. Let's write quit. So that should save my fstab file. Now this will actually validate that that update was correct. There we go. So it's going to go through and double check all of those. The 3 directories we're looking for is varop CloudBolt, the log CloudBolt jobs, and then CloudBolt static. So those are all mounted. So those have been copied over. They're correct on my first node. So now we're going to make the same change on the secondary node. Save that, and then we're going to run our validate command again. Okay, so we're good on both nodes. Our file systems are mounted. All of the files have been moved over. So if we go over, I'm already there. So if I'm in ProServe, actually cd var mount CloudBolt. It still thinks it's in the old ProServe, I believe. There we go. Now we can see the files, everything that have been moved over with the ProServe directory. So we know that we're mounted from our instances. Before rebooting instances, one of the things that I have run into is with the firewall disabled, we can actually wait till that comes back up. I'm going to add in a recommended command, but let's go ahead and reboot for now. On both nodes. So secondary node, sudo reboot, and we'll come back to them once they're back up and functioning. Okay, now both of my instances are up, at least as far as like being able to talk to them over SSH. I've already done this process with one of my nodes. I had some issues with the first video I recorded, so we're only going to do the second node here. You will have to perform these steps on both nodes. I did update the docs to reflect what I had run into. So there's a couple of changes that can be made depending on how your operating system is configured. There are two roads that you can take. One for if you have to set enforcing for SE Linux, and that's an organizational policy. There is a documentation link in CloudBolt that will walk you through making those settings. So you'll need to go through this. It can be pretty extensive. Get all of this set up and functional on both of your nodes for it to work. For this example, we're actually going to run through just setting SE Linux to permissive mode. Really quickly for this session, we can just do the set enforce 0, and that would make this functional again. Let's go back to my instance, but we're not going to do that. So we're going to start with that so that it is set for this session. That will enable CloudBolt to restart here. But then I also want to set my SE Linux config to be permissive out of the gate. The reason that this got set on a reboot is because this is set as enforcing in my config file. So I can set this to permissive. I can write the file, and then on next reboot, it should come up without any issues. Now what I can do is I should be able to restart both the job engine and the web server for CloudBolt. When those come back up, what we'll do is we'll see if we can get to the UI. I already know from my other instance, we're also going to have to make some changes to the firewall. So we'll jump into that once that comes back. But let's just validate that we're seeing similar conditions. Let's go ahead and refresh. It looks like the page is still dying. I'm fairly certain that's because of the firewall. A real quick way to test that is just do a systemctl stop firewall D and then restart CloudBolt and see if you can. Actually, you don't even need to restart CloudBolt. You just need to access it once you've stopped firewall. But we're going to keep firewall D up and running. I just want to make these 3 entries to ensure that they're set up. We're going to reload our firewall. Again, don't even need to reload CloudBolt. We should be able to come over here, refresh, and it should give us a response to our site pretty quickly. So we have our first and second nodes now available through the UI, so we should be able to get to them individually on either node. So let's just check on each. So I'm going to use, remember my original user, I think it was cbadmin. Okay, so this is on the first node on 208, and I'm going to just check on 224, just be sure that I'm able to log in here as well. Okay, it looks like both of them are logging in. It may even store the same session in my cookies and with the database, but both of them are logged in, meaning that the database is functional. We should also be able to go to all admins, and then there's a system status just to verify that what we need is up and running. So double checking the system status. Notice all of my health checks are up and working. I'm not seeing anything getting blocked. I could check that on both nodes. I think it's actually in the database. So notice we do have some challenges with my other nodes. So good thing that we checked this. The reason being is on my primary node, what I did is I actually went through and set some of those, the actual SE Linux commands, but I missed some services here. So I would need to go back through this entire document to re-enable all of those. I'm just going to set it back to set enforce. If SE Linux is a requirement for your organization, you should have someone on staff that understands that can help with it. But we also have, like I said, that document that we have as helper files as well. So set enforce 0 and then VI. Where was it? SE Linux. Set this to permissive. And once it comes back up, we'll just validate that in the browser, we're seeing the expected health on this node as well, which we should. Okay, we'll see. I just restarted and all of my services are green now. You'll also notice that I did add that to the dock. So just checking system status is another good way to ensure that everything is running as expected in CloudBolt. Okay, so we now have 2 CloudBolt nodes that are connected to our NFS share, as well as operating with our Postgres, our shared Postgres database. And the last thing that we need to do to get HA up and running is to create an Azure load balancer. If you recall earlier in this video, I did create this with my virtual machines. So we are going to check what that load balancer looks like. We're going to validate that it works. We may also set some certificates to validate that the certificates are working as expected as well. So let's go ahead and move forward. There's also an option to leverage an Azure application gateway. I'm going to change the recommendation here. I think that both options are viable depending on what your specific requirements are. I think that Azure load balancers are probably significantly less overhead to stand up and maintain. So that's what we're going to focus on for this video. If you have requirements for an Azure application gateway, it's something that we can help with our professional services, or your technical account manager can help work through those things for your specific environment. So let's go ahead and jump back over to our CloudBolt window. Let's get this aligned left again. We're going to go back over to our resource group. So my HA demo resource group. And from here, what I can do is I can find my load balancer. There's my load balancer. So this is a load balancer that was created with my virtual machines. They're already set up in a backend pool. So you see both of my nodes are set up in the backend pool. My front end IP configuration is stood up. And the other thing I wanted to check was the load balancing rule. So here we have the load balancing rule that was created. It is testing on port 443, targeting a backend port of 443. It does have a 443 health probe. The original documentation recommended port 80. I don't think that's actually needed because we're just not doing a ton with port 80. You could probably open that up because it will redirect to HTTPS. So I think that's more of an optional step for your organization. So I'll probably update this to remove the port 80 rules here. I'm going to leave the rest of this as is. The only other question I have. So let's start. We're going to start with the IP address to see if we can hit this load balancer on the IP address, and then we can start to work in some certificate specific functions. So where is an IP address that I can copy? Okay, so this should be balancing between my nodes. Okay, so mine actually said it doesn't support a secure connection. I didn't have HTTPS in here because port 80 wasn't open. It didn't redirect automatically for me. So maybe that's something you want to add. Let's try it with HTTPS. There we go. We're already getting a response. So if I wanted to, just to make this easier on customers, if they're trying to go to mycmp.myorg.com, what we could do is in the front end configuration, sorry, not the front end configuration, the load balancing rules, we could add an additional rule for port 80. And what that does is it gives us front end config, back end pool, IPv4, TCP, and we're going to do 80, port 80. Port 80 health probe. I can't select 443 because I wanted to actually check port 80. And this should do the trick. Let's just verify. Should trigger the redirect. There we go. So notice it's rerouted me to HTTPS from port 80. So maybe that's worthwhile adding in just a convenience for your end users. Next step, I'm going to go generate a certificate just so we have something to test with, just to be sure that we're able to hit SSL. And then we'll do some low-level HA testing to round things out. Okay, we're going to go ahead and set up our SSL certificate. So I have a real basic kind of POC environment set up. I created a new certificate. It is issued by, it's a local certificate, so I have installed it in my local trust store on my computer. If we look at the details here, one of the things I will call out, the subject alternative name. I did put a name in for what will be my load balanced IP, as well as an entry for each of the instances of CloudBolt I may need to connect to. This would replicate real DNS entries in your specific environments. The other thing that I did do is I updated my host file to have the real IP addresses targeting the correct host names so that I can resolve those. So the last thing I should need to do is to go through and update my CloudBolt appliances to have these certificates available to update them. So let's just look first to see, let's just refresh. Okay, this is my primary node. I think all we have to do is, we'll do most of the work on the primary node, but if we look at my certificate here, you'll notice it is a very basic self-signed certificate. You know, this will come through to be the certificate with the subject alternative names once we have it updated. So let's go through the process to do that first. We'll start with the CloudBolt documentation for updating certificates. So we'll keep this up so that we can reference it as we go through. I don't like this little menu. It doesn't want to pull things up. There we go. SSL certificates is what we want. So you will notice that each of the paths, our certificates are stored at specific paths in the CloudBolt appliance. These are not paths that are stored on the shared drive. So you're going to have to update the certificate on each one of your nodes individually. So let's go ahead and put this over here. And then I can go to, I don't even remember, let's start with, so this is not going to be in the Azure HA documentation. This is a little bit above and beyond. We have certificate stuff everywhere. This is just a bonus extra credit portion of the video. So we're going to go to, in my CloudBolt appliance, I'm going to and then let's see. So we have the localhost.cert already. So I'm going to move localhost.cert to localhost.cert.old. And then I'm going to vi localhost.crt. So I'm going to input the information. Have it all here. So cat cmp.crt. Did I'm not in the right directory because I moved them all. C tools. There we go. So here's my private or my public certificate, which will be in my localhost.cert. Okay, so we have our localhost.cert. We'll reset the permissions together here in just a second on both of those files. Then I'm going to cd to private. Oh, that's the wrong server. I need to do that here. CD private. It's never going to work on my machine. Let's just check out what's in here. So again, we're going to move localhost.key to localhost.key.old. And then we're going to vi localhost.key. And we're going to cat key file. So we have our public key, our private key. We're going to save that. Next thing we're going to do is run this command. This will reset the ownership and the permissions on both of those files simultaneously. No errors, so we're good to go. And then we should be able to do a service HTTPD restart to see those certificates show up on the servers. So I'm going to start on my first node, 224. Let's restart. There's privacy error. Once that loads, CMP HA demo. So we're seeing the new certificate added in here now. I think the subject alternative names I have to download to see. There we go. So we see all three of our subject alternative names. So we know that the new certificate's available now. So then we need to move on to the second node and repeat the exact same steps that we just did on the primary node. I'm not going to make you sit here and watch me do it. So I'll make those settings and be back in just a second. Okay, so both nodes I know that by IP address have the correct entry right now. I don't know. I do want to check now via URL to make sure that these are working. So let's just double check. We shouldn't see a certificate warning here. Okay, that's exactly what we want to see. So no certificate warnings on node 1. Then if we go to node 2, should see no certificate warnings. And then finally our load balancer, if we go to cmpha demo.local, this should come through with no certificate warnings. All right, hit a little snag there. It turns out it was a typo on the IP address of my host file. Once I fixed that, we are up and running. We can see that we are now connected to that cmpha.demo.local. We do have a secure connection because we have certificate validation on my computer as well as a certificate installed in CloudBolt. We can check the certificate information, just view that it's here and then see the subject alternative names. So we have everything that we need at this point. It looks like high availability is up and running. The next thing I want to do is I want to bounce each of my, I'm going to log in. Okay, so I am now logged into CloudBolt. I want to take each of these nodes offline and just refresh and see what happens. So I am on CMP02 right now, so I'm going to take it down. I'm going to set this. Okay, so now if I refresh on my dashboard, so administratively, I'm still connected. Now, what could have happened is I could have been connected to CMP01 in the first place. So I'm going to bring CMP02 back up, or none, I guess. Oh, and set the setting overrides the health balance or health probe status. So I could force it to be up. I don't want to do that. I'm going to take this node down. So node 1 is now back to none. So the health probe should take over, and node 1 is down. Node 2 is set to none. So let's refresh my page here. And notice it redirects me over to node 2. So we see that we're working through HA at the application layer. The database layer, that's offloaded to Azure, so that should all be handled as well now. So I think with that, we've very thoroughly covered off setting up high availability in Azure, leveraging the documentation. So we'll work on getting those documentation updates pushed out. If you have any questions, please reach out to your CloudBolt account team. This concludes another video in the How Do I Do Something in CloudBolt video series. If you've made it this far, thanks for sticking around. And if you have any questions, if we can help with anything that you've seen here today, just to elaborate a little bit further, if you have any feedback for other ideas for the series, please reach out to your account executive. Thanks again, and happy cloud bolting.